Magnatele sucatelo stu limone, ilu sace catete piace.
Okay, as promised, this section and probably the next two are substantially easier than the previous couple of sections. That doesn't mean that everything going forward for the rest of the course is going to be super easy, but this is probably much easier than what we just covered. So what we are going to talk about is different types of chemical reactions. So imagine that there are a million zillion different chemical reactions out there in the world. However, even though they're all different from each other, some of them are similar to each other in certain ways. So chemists, like other humans, like to classify things. They like to put things into groups. What they like to put into groups are chemical reactions. They like to say these chemical reactions over here, they're all alike in a certain way. And those chemical reactions over there, they have certain features that are similar to each other in other ways. So we're just going to cover, I think, maybe 4, maybe 5 different types of chemical reactions. First type is called a combination reaction. Sometimes it is also called a synthesis reaction. You can think of these names as being synonymous. They mean the same thing. This is pretty straightforward, at least with the name combination. In a combination reaction or a synthesis reaction, 2 or more things combine to make one thing. So if I was going to show you a generic chemical equation, it might look like this. Here's some material. It has a formula A mixed with another material, formula B, but they're separate from each other. There's a plus sign. You do some magic, and all of a sudden they're stuck to each other. They combine. And because of that, it's called a combination reaction. Now, it doesn't have to be one A and one B. It could be AB2, could be AB95, it could be A97B3. As long as these the elements in these formulas, and these could be complicated formulas, as long as everybody ends up together in some form, then it's a combination reaction. Or you can call it a synthesis reaction. Here's a concrete example of a combination reaction. This is sulfur. If you take solid sulfur, mix it with O2 gas, under the right conditions, those materials combine to make one thing, SO2 gas, and this is just an example of a combination reaction. There are plenty of other combination reactions. Another example would be 2H2 plus O2 makes 2H2O. This is an equation that we've covered a lot. We balanced it. But if you notice, there are 2 or more things on the left side of the arrow. There's some H2s and O2s. And they combine. They combine to make water. They make one thing. So this is another example of a combination reaction. This one is also pretty straightforward. It's called a decomposition reaction. You can also think of it as the reverse of a combination reaction. That's all it is. One thing breaks apart into 2 or more things. So, just to show you in reverse, if I have a bunch of elements stuck to each other, represented by A and B, I do some magic, and the elements split apart in some way, then that's a decomposition reaction. So if I ran, the reaction I showed you on the previous slide was this, 2H2 plus O2 makes 2H2O, and I said that was a combination reaction. If I ran the reaction backwards, which you can do, if I said I start with 2H2O, and I make 2H2, and I turn it into 2H2 plus an O2, this is an example of a decomposition reaction. Here's another specific example of a decomposition reaction. All of these elements are all bundled together. They're all attached to each other in some way. I add some heat. Doesn't really matter that I add heat. All that matters for a decomposition reaction is you start with one thing, and it breaks apart into 2 or more things. And here's thing 1, here's thing 2. So that's an example of a decomposition reaction. There is something called a single replacement reaction. In a single replacement reaction, you have 2 materials, maybe 2 elements. That might be the simplest way of thinking about it. They're a pair. They are a pair. They're stuck to each other. Then you have something else alone. And what happens is your single thing, the one that's alone, replaces one part of the pair and makes one part of the pair alone by itself. So watch this amazingly awesome animation. Here we go. A comes along, kicks out J. This now is single. And this one that used to be single replaced it. So now this is the pair. And so this is called a single replacement reaction. One single thing is replacing something else that ends up being single. If you've ever heard me give this lecture before, this is a little bit dated, but probably most people still know this. This is supposed to be Angelina Jolie. This is Jennifer Aniston. I don't know how to spell her name. And this is Brad. And, you know, that tramp, Angelina, comes along. She kicks out Jennifer and ends up with Brad. But that is basically a single replacement reaction. It's not a chemical reaction, or maybe it is on some deeper level, but for us it probably isn't. So let's see. So if you were going to draw that in traditional chemical equation form, it'd be Angelina all alone, Jennifer and Brad together, then all of a sudden Jennifer's eating Haagen-Dazs and watching Netflix or whatever the hell she does, and Angelina and Brad are together making movies and walking on the red carpet. So, single replacement reaction. Here is a more concrete chemical version of a single replacement reaction. Zinc, all alone. Let's call it single. It's a solid. That's not really relevant, but I'm just pointing out some other things. These two guys, the Cu is copper, Cl is chlorine. They're a pair. Happens to be dissolved in water. But then guess what? Zinc comes along, makes its move on chlorine, and kicks the copper out. So copper ends up single. So one single thing replaced something else that became single, and the zinc ended up with the chlorine. So that's an example of a single replacement. Guess what? If there's a single replacement, there's also a double replacement. Double replacement is maybe a little simpler to explain. You have two pairs of things. So here I have S and H and F and B, and in a double replacement they basically swap. The partners swap. I didn't make this one up, but one of my students once told me this is Shania Twain. I think she's a country singer, and her husband, and this was Shania's best friend and her boyfriend, and somehow, well, they changed. They swapped. So that is a double replacement reaction. Sometimes those are not as easy to see in real chemical equations. Here it is written out as you would see it in an equation. S and H are together, F and B are together, but then they swap. Let's see, F goes with H, and S goes with B. Here's a real example. This one, it's easy to see the pair. H is one part of the pair, chlorine is the other part. So this is number 1, this is number 2. Here it's not so easy to see the pair. The Na is one part of the pair, that's sodium. The OH is, if you remember from much earlier in the course, it's a polyatomic ion. That is a pair, that is part of the pair, that's thing number 2 in the pair. So basically these two things can connect or split apart. These two things can also connect or split apart. And if this is a double replacement, what happens is they swap. So in this case the H goes with the OH, and if you have H and OH, this is just a weird way of writing water. So on the right side of our equation we made water, and the Na swaps into and pairs up with the Cl. Na and Cl, that's table salt. So this one, it might not be quite as obvious looking at it that it's a double replacement, but it is. H goes with the OH to make water. Na goes with the Cl to make table salt. So that's a double replacement. This might be the last one that we talk about. It's called a combustion reaction. It's maybe a teensy bit more complicated than the others. I will try to give you some guidelines as to what makes a combustion reaction. Basically, you have some chemical. I'm just going to say that its formula is A. This could be a complicated thing. You have to have O2 gas on the left, so must have O2 gas on left. And then the A and the O2 and the oxygen have to end up stuck to each other. Again, it does not have to be AO2. It could be AO, could be A2O, could be A55O3. But as long as the A and the O end up stuck to each other, and you release heat or energy, then it's a combustion reaction. So that may be confusing because there are many different features you need. You need some material, which I'm calling A. You need O2 on the left. You need both of those things. Those things have to end up combined in some way, and you have to release heat or energy. What I will tell you is that on a quiz or a test that I administer, the only thing you really need to look for is O2 on the left and heat or energy on the right. That will be enough of a tip-off that you have a combustion reaction. So you don't have to sort of memorize all the additional details. So stuff plus O2 makes a bunch of stuff attached to the oxygen and energy. Here is an example of a combustion reaction. You don't need to know what this is called yet. You'll know later in the course. But this is called methane. We have O2 gas on the left side of the arrow. Here it is. Apparently we need to heat them up. Some of the O's end up with this carbon. Some of the O's end up with those H's. And we also release some energy. So this is an example of a combustion reaction. We've got O2 on the left. We've got heat or energy on the right side of the arrow. That's what you should be looking for. For those of you who've taken biology, this is another example of a combustion reaction. Again, just to pick out the relevant points, O2 on the left, energy on the right side of the arrow, and to be a little more formal, these O's, some of them ended up getting stuck to the carbons. These O's, some of them ended up getting stuck to the hydrogens. So this is an example of a combustion reaction. Again, for those of you who've taken biology, this is formula for simple sugars like glucose. Glucose is a relatively simple sugar that we can eat and get energy from. What do we breathe in? To stay alive, we breathe in oxygen. What do we breathe out? We breathe out carbon dioxide. We also make some water, and we can get energy from our sugars. So this, in biology, you don't need to know this for this course, but this is called respiration, or this is the simplified equation for respiration. And respiration is a type of combustion reaction. It's a fancy one, but when you boil it down to its simplest pieces, what it is combustion reaction. So those are the 4 types of reactions that I want you to be able to recognize. So if I show you a chemical reaction, you should be able to say, oh, is it a synthesis / combination? Is it a decomposition? Is it a single replacement? Is it a double replacement? Or is it a combustion? I guess that's 5, so I cannot count, but you should be able to recognize or categorize whether a reaction belongs to one of these categories. One thing to point out is that you can have a reaction that belongs to more than one category. An example might be this. I'm rolling this one out again. This is, you start with 2 things, you end up with 1 thing, so it's a combination reaction. But you also have O2 on the left, and you have energy on the right, so it's also a combustion. So you can belong to more than one category, just like you can belong to more than one organization in real life. So that's it for categorizing equations. A couple more videos, also pretty straightforward, coming up.